Now I want to take a few minutes and just give you an overview of the Android platform, specifically how a developer approaches the Android platform. So let's first look at the architecture. So Android runs on top of Linux 2.6, and it uses a virtual machine called Dalvik, which is particularly optimized for mobile devices. It has an integrated browser based off of the open source WebKit engine. It has OpenGL ES, which is the embedded version of OpenGL for high performance 2D and 3D graphics. And it uses SQLite as a database for structured data storage. So now I want to quickly talk about Android versions, because Android has been progressing at a really fast pace, and it's difficult to keep up with the different versions that are out there. So when I first got into Android, the first release was Android 2.0, which was called Eclair. The next one was Android 2.2, which was named Froyo, and this is the version that's probably on most people's phones today as I record this. The very latest version of Android for phones is 2.3, which is known as Gingerbread, and that's what we're going to be targeting in this course. Now there is Android 3.0 Honeycomb, but what's unique about this is it's geared only for tablets. So some of the new tablet devices, such as the Motorola Xoom, have this new version of Android targeted at tablets. So in the future, and again, this is the latest news that we have, the next version is going to be called Ice Cream Sandwich. And this is actually going to be a combination of Gingerbread and Honeycomb. So it's kind of bringing these two versions together, and it will be a unified OS version for tablets and phones. So that's the recent Android versions that are out there today. So let's look at some application fundamentals. So obviously, Android applications are written in the Java programming language. So when you write your application and compile it, you compile it into an Android package file, which is a .apk file. And this APK file is the file that you upload to the Android market or the Amazon App Store in order to distribute to everybody with devices. So each application runs inside of its own sandbox, protected and isolated from other applications. And they also run in their own Linux process. So your applications are going to consist of components, a manifest file, and resources. And resources being anything that you include with your application. Images, video, audio. So what are the components that you can include in your application? Well, there are 4 main components that can be used to build Android applications. They are activities, services, content providers, and broadcast receivers. So let's look at each of these individually to learn a little bit more about them. So activities represent a single screen with a user interface. So you can think of it just that way. When the user sees a screen, that is an activity. So if, let's say, we talk about an email client, when the user comes in, they see a list of all their emails. That's one activity. When they click on a specific email to actually view that specific email, that's another activity. Say they want to compose a new message. That screen which allows them to compose the message is another activity. So it's a single UI screen in an application. Now, most applications obviously contain multiple activities. They don't have to, but generally speaking, there's going to be more than one activity in an application. So when a new activity starts, it's pushed onto what is called the backstack. So let's say I have an application, and the first screen that the user sees, they click something to launch another activity. That initial activity is paused, and the new activity is brought to the front over top of it. But if the user hits the back key, it's actually going to pop that current one off and show me the one that was there before. So again, this concept of having a stack of activities that the user can navigate back and forth through using the back key. Now, the user interface for activities can be built either with XML or directly in Java. Now, definitely the recommended approach, the one we're going to be focusing most in this course, is to build the UI in XML because it gives you a nice separation of UI code and kind of Java code logic. So now you can monitor the lifespan of an activity through a variety of callback methods, such as on start, on pause. So you can respond to these methods to do certain things when these things happen in an activity. So services are what you use to perform long-running operations in the background. Now, services don't contain any user interface. They're definitely useful for things like network operations, playing music. So you can imagine in a music application, if I start something playing, the music is going to continue playing no matter what I'm doing on the device because it's actually going to be running inside of a service. Services run independently of the component that created it. So if I have an activity that launches a service, if I close that activity, the service is still going to be running. So now services can be bound to by other application components if you allow them to. So as you create your service, you can say, hey, any application can actually bind to this and manipulate it. So content providers are used to store and retrieve data and make it accessible to all applications. Because by default, there is no way to share data across different applications. The only way to actually do it is to use a content provider. And the way this works is it actually exposes a public URI that uniquely identifies the data set. So if I have some data that I want to expose to other applications, I can create a content provider which these other applications can actually connect to. So the data is actually stored and exposed just using a simple database model concept where you have a table on a database. So Android itself contains many content providers which you can access, and these include things like setting and retrieving contacts, media, and things like that. So there are many built-in content providers already for you to access. The last component is broadcast receivers, and this is a component that responds to system-wide broadcast announcements. So there are many of these that happen, and some examples are, say, when the screen turns off. Android actually sends out a broadcast which any application that's listening for that can respond to. Another one is when the battery is low, when somebody has taken a photo, and things like that. Your applications can also initiate their own broadcasts that different applications can respond to. And much like services, broadcast receivers contain no user interface. But the one thing that they can do is to create status bar notifications to alert the user. So if you detect or if you receive a broadcast, you can alert the user by creating a status bar notification. So the last piece here is the Android manifest file. So all applications must have an Android manifest file exactly named Android manifest.xml, and it has to be in the application's root directory. And the purpose of this file is to give the Android system information about your application. It describes the components that you're using in your application. So those things that we just talked about, activities, services, content providers. It also declares the permissions that are required to run the application. So if you've ever installed an application from the Android market, you'll know that before you actually download and install it, it presents a screen telling you which permissions that this application is requiring, whether it needs internet access, whether it needs to access certain features on the hardware. The other thing that it does, it declares the minimum Android API level that the application requires. So let's say in our application, we're using some new Gingerbread feature. So if we set the minimum API level to 10, which is Gingerbread, only people with Gingerbread enabled phones are going to be able to see your application in the Android market. So again, that's a quick overview of the Android platform, but all of this will start to make more sense once we jump into some code, which we're going to do next.